There, geometry folk. We're going to continue on the unit for tools of geometry with the next section in the textbook, really about measuring segments. And with this particular section, what we're going to get into is some concepts about distance, addition, subtraction, congruence, equality, some neat stuff. And so there's a quick bit of notes here in the book, and then a couple of activity questions that we'll be able to get into to help us understand some of the things. But first, I want to talk about the concepts here, mostly about distance. Well, it gives this example with a particular line that talks about some segments. You know, it's asking, is segment AB and congruent to segment CD. So we'd have to look at segment AB and then wonder if that's congruent to segment CD. So it goes over, how you do that. Well, first let's talk about distance, because everything is pretty based on vocabulary. So the first vocabulary piece that we'll get into is distance. So what is distance? I mean, that's a neat thing to ask. So the very basics, distance is from one point to another. When you're looking at a line segment or a line or anything that has positions, it's from one point to another as a distance. And we kind of talked about what can be measured in the previous lesson. So, we can't measure a point, but we can certainly measure the distance from one point to another. So how is it that we find distance, right? And the book shows you a fun way that deals with absolute value. You're looking at the coordinates on the line based off of the postulate about every point having a real number coordinate. So it shows you look for the coordinates and subtract them and then find the absolute value. Yeah, that's definitely a way that you can find distance, right? So how is it that you find distance? Well, yeah, you can totally do that. You can subtract the coordinates and take the absolute value of that amount. That would be the distance from one point to another. Or count, right? Why not count? So if you look at this example, right, it's showing you absolute value. So why not count? How far is it from the coordinate A to coordinate B? Well, here's A, here's B. Let's count. 1, 2, 3, 4, 5. Oh, great. 5. And then how far is it from coordinate C to coordinate D? All right, here's C, here's D. Count. 1, 2, 3, 4, 5. Equal. Okay, so how do you find distance? You can subtract and you can use the absolute value, or you can count. So that's kind of the note. But then I said something kind of interesting there. I said equal. That gives us a whole other thing. So you look in the textbook. Now look at this. This might be the most confusing thing that you will find. Well, first of all, what is that symbol? So you look at this. Well, it says AB equals CD. So segment AB something is segment CD. Well, here we have AB and segment AB, and then CD and segment CD. What's going on, and what is that thing? So we have to get into this neat concept. We're gonna have a little throwdown here. You guys ready? Throwdown. Bam. We're gonna talk about equal versus congruent. So this congruent thing, we have to know what that means. Well, first of all, do we even know what equal means? What does equal mean? It means, well, it's exactly the same. Exactly the same is equal. This pen is equal to itself. It's equal to this pen. It's not equal to this pen. Well, it's a different color. But if I had like another blue pen, they wouldn't be equal because this pen is this pen, not any other pen. It's this one. So this pen is equal to this pen. It's exactly the same. Congruent, on the other hand, isn't exactly the same, but it has the same size and shape, the same exact size and shape. So if I had another blue pen, technically, the blue pens are congruent to each other, not equal to each other. Okay, here's an example. Here's a piece of paper. Here's another piece of paper. They are exactly the same size, shape, and color, but they are not the same pieces of paper. Only this piece of paper is the same as this piece of paper. This is equal to itself. This is not equal. This is congruent. So we have to know the difference between equal and congruent, and it's a very, very tricky difference. Okay, so let's continue going into this little smackdown. First of all, we got to know we have symbols for these things. Equal sign, that the one we grew up knowing and loving, is the equal sign. It means it's exactly the same thing, right? So we would not put this piece of paper equaling this piece of paper because they're not the same thing. This is only this piece of paper. This is actually this piece of paper. They're not the same thing. They're actually congruent. So this is the symbol for congruent. We take the equal sign we grew up knowing and loving, and then we throw a squiggly on top of it, and that's the symbol for congruent. So technically, we have to know the difference. It's a crazy nuance that is quite challenging. So hopefully you did understand. Equal means it's exactly the same. Congruent means it has the same size and shape. So it's very, very hard to find two things that you can hold on to and touch and measure to be equal to one another. If you can measure it, or you can touch it, you can hold it, chances are it's not going to be equal to anything else because it's the only thing of its kind in existence. What is this guy talking about? So here we go. Now, measurements. Measurements themselves can be equal, right? 2 inches can be 2 inches wherever in the world it is. Okay, so measurements can be equal, no doubt, right? 2 inches is 2 inches no matter what. Now, different shapes are not equal, they can be congruent. Okay, so 2 different segments, in this case line segments, 2 different segments can totally be congruent. They can have the same measure, but they are not technically equal. They're not equal because, like we said, they're different. It's a very challenging concept. So we capture all of this amazing information into one little thing here and expect you to know that. So you're expected to understand everything I said just by looking here. And it's more than that, right? It's totally more than that. And we have to know the difference. Okay, so there's a difference between equal and congruent. That's an important difference to know. All right, another thing you may think you know, let's make sure you do, is this concept of addition. So what is addition? When it comes to numbers, you're really like gathering together. But when it comes to stuff, you're like putting together. You're attaching to make things. So here's an example. I'm going to use this, that, and the other. You ever heard of that? This, that, and the other. So we're going to talk about this, that, and the other. So if I take something that's this, and we'll call it a thing, like we'll give it a value, like a little segment. Let me hide all the other stuff. So let's take a thing like this, and we'll say it's like a distance from one point to another, from A to B, and we can either call it segment AB or the measure of that segment AB, the measure of AB, where there's no line of that. That's how you read that. So it's either segment AB or the measure of AB. And you're going to add it to that. Okay, so if you add it to that, and let's say that is this whole other thing. So let's say that is another segment that has BC, and just for the sake, we'll say B also exists with that, and it's a measure there. And we can call that segment BC or the measure of BC. And if we take this and add it to that, we get the other. So I'm going to use this, that, and the other. So if we take this, add it to that, we get the other. So it equals AB, segment AB, together with segment BC, gives us this whole other thing. It gives us like AC from here to here. So if we take this segment and this segment, throw it together, click, click, then we get AC. Ta-da! So that's what addition is, right? I know you're thinking cats. Come on, really? Duh. Well, hang on, because it's kind of a tricky thing, because it means another thing. It means, what if I take the other, what if I begin with the other, and then I start removing things from it? What if I remove stuff? Right? So if I have the other, and I decide to remove a thing, let's say minus this, right? So let's say if I take the other and I minus this, I take away this, what will I be left with? I'll be left with that, right? So that's the whole concept of addition. I know you're thinking, well, really? Duh. Well, it's not quite duh. Because it's just, you have to understand this concept, what addition is. If I can combine things to get another, then I can remove things from the other to get the things that I combined originally. It's like the whole building block of understanding mathematics. Anyhow, that's enough of notes, right? So we're done with notes. We're going to take all this information, and then what we can do then is answer these little practice questions to make sure we get what's happening. And so we see in the practice section, we get this little diagram and saying for exercises 12 and 13, use the number line below. So here's this number line. Got some stuff going on. So number 12 says, find two possible coordinates of Q such that, how do we read this? Such that the measure of PQ is equal to 5. So we get to find two possible coordinates of Q such that the measure of PQ is 5. And this is so tricky because you're thinking, well, where is Q? Look at the number 9. There is no Q. Well, we have to invent Q, right? So Q has to be invented. That's the whole goal. That's what we're doing. We're finding two possible Qs. So we have our number line. The only thing we're given is P at -2. So how in the world can I find a Q where the measure of PQ, the distance from P to Q, is 5? So basically we start at P, and we can either count, which I suggested we do for distance, right? I suggest we count. How do you find distance? Count. So we're going to count 5 spaces from P to see where Q could be. We can count 1, 2, 3, 4, 5. Where would that be? Okay, so this is P at -2. That would be -1, 0, 1, 2. That would end up being at 3. Okay, so Q could be at 3. Okay, or we can go the other way because it says find two possible coordinates of Q. All right, so we can go this way. 1, 2, 3, 4, 5. Right, hopefully you saw what I just did because you're thinking cats, you didn't have anything else there. I know, but it's still there. So we'd have -3 here, and -4 here, and -5 here, and -6 here, and that would be -7 here. So we can have Q also at -7. So when the question is asking, find two possible coordinates of Q such that the measure of PQ is 5, it could be at 3 or at -7. Okay, so it could be at 3 or -7. That's how we'd answer number 12. Okay. So now we move on, number 13. Well, let's see what number 13 is all about. So number 13 says, use the number line above, sweet. Find the coordinate of the midpoint of segment PH, right? That's how you read that. You read that as segment PH. Okay? So we look, here's P, here's H. And what are we going to find? We're going to find the midpoint. Well, what's the midpoint? Midpoint is simple as it sounds. The point right in the middle, right? Midpoint right in the middle. So here's P and here's H. What's in the middle, right? So from P to H, we got 1, 2, 3, 4, 5. So there's 5 spaces from P to H, which would be the middle. And you might think, well, maybe it's 0. Is 0 the middle? Well, I don't know. Well, if 0 were the middle, we'd have 1, 2, 3 to H, 1, 2 to P. That can't be. Maybe it's 1, right? So here's the coordinate of 1. Maybe we have 1, so we got 1, 2 to H and 1, 2, 3 to P. Well, that's not the midpoint either. So what's going on? If we're going to use the number line above to find the coordinate of the midpoint of PH, and it's not 0 because that ain't right, and it's not 1, that ain't right, what's going on? It could be in between 0 and 1, which is exactly where it is, by the way. So it's right in between 0 and 1. Because if it was in, like, let's say it was 1/2, which is what it is. So let's say it was 1/2 here. We have 1, 2.5 to get to H, and then 1, 2.5 to get to P. So it's at the 1/2 mark. Even though it's not a tick on the number line, it's still there. So the midpoint, most definitely, is 1/2. It's a real number. Okay, so you got to remember from that postulate, every point on a line corresponds to a real number. Half is a real number. Okay, so that's how we would handle number 13. Now we go to number 14. And here comes algebra. Number 14, it says, find the value of m. Now, what in the world is going on with this picture? We have to know a few things. So we look at this picture and we got to know a few things. First of all, we have a segment AB and a segment BC adding together to give us one giant segment AC. But what's happening? Do you know what these little tick marks mean? These little tick marks, there's only one tick mark here between A and B, and only one tick mark here between B and C. That means they are the same length. Okay, so they are congruent segments, or they have equal measures. So the one tick means they are the same. Okay, means they are the same. Okay, so one tick means they're the same. So that means this from here to here is the same as from here to here. Now, what does that mean? Well, we're throwing algebra at you. Okay, so we're going to want to throw some algebra at you. What does that mean? That means that, well, if from here to here is 3m plus 5, right? And from here to here is 4m minus 10, and they are the same, well, what does that mean? Right? Well, if they're the same, that means they are equal, and enter algebra. Okay? So if they are the same, that means the measures are equal, right? So if the measures are equal, we can set up an equation, and now we just solve. And if you don't remember how to solve equations, well, here's a quick down and dirty refresher. We have to undo stuff from each side. Undo stuff to isolate the variable. Okay? So we're going to undo stuff so we can isolate m. Okay? We have an m over here and an m over here. One of them has got to go so we can get them on the same side. We want to isolate them. There's two of them right now. So let me rewrite the equation, and then we can go from there. Now, if you don't remember how this works, I have a tendency to focus on the variable first. So what I'm going to do is undo 3m. How do I undo 3m? I take it away. And so I'm going to take away my 3m, and I have to take it away from both sides of the equal sign. And so I'll be left with 5 on one end. And then 4m minus 3m is just an m. That's convenient. And then minus 10. So what do I do now? Remember what solving equations means. I'm undoing stuff so I can isolate m. I got to get the m by itself. Well, what's there? There's that minus 10 there, and I have to undo minus 10. How do you undo minus 10? Well, with a plus 10. And you have to plus 10 on both sides, right? So there you go. 5 plus 10 is 15 is equal to m. Guess what? M is isolated. We have now found the value of m. So m is 15. Normally here, I don't circle this yet because I want to read the question again. We're on number 14. It said, find the value of m. That's all it was asking for. We found the value of m. Where you have to be careful, ladies and gentlemen, is what if this instead said, find the distance between A and C, right? Then you'd have to plug m back in, use some substitution, and crunch some numbers. So you do have to be careful. I have a tendency to ask questions like that. I would rather say, find the distance or the measure of segment AC. That's what I would have done. Anyway, on to number 15. So let's read this one carefully, and then we'll be done. How do we read this? If the measure of xz is 50, what are xy and yz? What? So we look, if the measure of xz is 50, what is xz? Here's x, here's z. That means the measure of xz is 50. So I know from one end to another, it's an entire measure of 50. That's what I know. Then the question is, what is xy and yz? Well, remember what we talked about with addition. Okay, so this is where the addition piece comes in. If we're talking about this plus that equals the other, right? If this and that equals the other, and the other is made up of this and that, that's how addition works. So if we're looking at the segment here, and the whole thing is 50, and the whole thing is made up of this and that, right? So if we add this and that, we get the other. That means we have to add a and a plus 8. Okay? So we have to add a and a plus 8. If we add them together, we get the whole thing, right? Now, I used grouping symbols for a plus 8 because it's an important thing to remember to do. So if I add this and that to get the other, I'm adding a plus 8, that will give me 50. That's what the other is. It's the measure of the other. So we have to remember that. That right there is the hard part. Hard part's done. If you understand that, then you understand addition, right? So that's why I spent so much time talking about addition, because that's not the easiest thing in the world. So from here, we just simplify, right? So you remember, simplify before solving. So I have a and a plus 8, right? So a plus 8, that's going to equal 50. And now I'm going to combine like terms. That's what simplifying is. Here's an A, here's an A. How many are there? There are 2 of them. So 2 A's. 2a plus 8 equals 50. The rest is undo. Right? So we're going to undo plus 8 with a minus 8. Then we have 2a equals 42. And now we have 2 a's. That means there's 2 times. It's a 2 times. How do we undo 2 times a? Well, we divide by 2. And so a will equal 21. That's the value of a. Okay, so once again, before you circle your answer and say, well, the value of a is 21, read the question again. See, we had to go back, right? Because it says, what is the measure of xy and the measure of yz? That means the measure of xy is a, and a was 21. And the measure of yz is a plus 8, so it's 21 plus 8, or 29. So that is the actual answer. Okay, so you gotta be careful. You gotta be careful of that stuff. Anyway, I just wanted to show you those concepts. That's how you do the activities, and the rest is gold. Go have fun.